Yes. Is it visible, guys? Yes, guys, this my screen visible. Akib and Prishida, can you guys see my screen?
Yes, sir, it's visible.
Now, let us start what we will. So we were solving the equations of the motion using the graphical method, right? So we solved the first equation, and then we also solved the second equation, right? So so far, how much we have covered? So let me. Yeah, my voice is low. Let me increase the volume. Is that okay now? Yeah, is that okay, Akib? Now let us quickly recap what we have done. So quickly, right? In motion in one. So we talked about what is the frame of reference, right? And from frame of reference, we talked about the rest and motion, right? And then we talked about that. Yeah. So then we talked about the attributes of motion. So this was first was what? First was distance, right? And then we talked about displacement, and then we talked about heat, right? And in that we learned that it is of two types. The first one was uniform, and then non-uniform. And in non-uniform, we learned that it is of two types. So average and then instant, right? And then we learned about velocity. And again, we learned that it is of types uniform and non, right. And again, for non-uniform case, it is of two types. One is the average, and then this we learned, and then we learned about the acceleration. So in acceleration, again, we learned about uniform and non. And for non-uniform case, again, we learned about average acceleration and instant, right? So this we learned about the attributes of the motion. And then we learned about the uniform acceleration. For uniform acceleration, we saw that there are three equations of motion. So first one was the V is Q. plus at. Then we learned about S equal to ut plus half at square. And then we learned about v square minus u square equals to. And lastly, we also found out that what is the speed at ts second. This was plus a and 1 minus of t minus 1. This we learned, right? And similarly, this was in vector form. This was in vector form. And the second equation was f, which is ut plus half a t. And then the third equation we solved was minus u dot u is equal to and a dot. So these were the equations. Okay. And then we talked about motion under gravity. So these are things we learned, and the last thing we learned was the graphical of equation of this we were doing, right? And we solved it. Yeah, my voice is lagging. So is this okay now? Yes. Is this okay now?
Yes, sir.
Yeah. Can you guys? Okay. Yeah. So no, it's still lagging. Okay. So what should we do? Let me check the internet. Okay. Yeah. How about now? Yes, is it okay now, Akib? Okay. So now we were talking about the graphical solution of equation of motion. So what we did was we solved the two equations. First equation we solved. This we solved, and then we were solved this we also solved. Right. Now the third one we will solve. So we have to solve this. Right. So from calculus method, so these equation we solved from the calculus method. This we also did. Right. Now let us solve this third equation. So which graph we will take? Rishita, which graph we will take?
Velocity time graph.
Yeah, again the velocity. So velocity time graph. And we are studying the uniform acceleration. So what is the graph of uniform acceleration in velocity time graph? Yeah, what is the graph of VT graph in the uniform accelerated motion?
It's constant.
It's constant in velocity time graph. It's a straight line, right? Constant, if a velocity time graph is constant, so this means what? This graph means what? That velocity at different point is same. So change in velocity would be what? If you are drawing a constant graph, then this is what? For these kind of graphs, so velocity is same, right? So if I calculate the acceleration, which is v minus u by t, so this would be v minus v by t, which is 0. So this represents uniform velocity, constant velocity. But for this case, acceleration is 0, right?
Yes, sir.
So for the case of uniform acceleration, the graph that we drew was this, right? So this was what? This was u. This was v, right? So let me extend this line. This was understood. This was the graph that we were drawing.
Yes, sir.
And I said that area under this graph, was the what? So the area under this graph was what? You guys have forgotten. The area under this graph was what? Akib and Rishit. The area under this
Triangle,
graph.
parallelogram.
I am asking about that. What is the area under velocity time graph? What does it give? Yes. What does area under velocity time graph gives? The distance, right? So
Yes, sir.
area under graph, this will give you distance. So we did this problem here. Right, slope of the graph will give you acceleration, but area under the graph will give you distance. Correct? Okay. Now let us get back to what the area under this graph would be. And what is the shape of this graph? What is this ABC?
Trapezium,
Trapezium, right? So, and what is the area of trapezium?
length plus breadth divided by 2 into height.
Uh, okay, so we have length plus breadth. So we have different kinds of
The
right.
parallel sides, we can
Yeah,
tell.
yeah. So then it is the correct. So this is half sum of parallel side, and then this is what? Height or altitude. Okay. So half of, and what are the parallel sides? So this is how much. This is how much from A to B. Yes. This distance is How much?
BA plus CD.
Yeah, BA plus CD. Wow. Okay, so let me write it. BA plus CD into this is CD. So what is BA? What is BA? On the y-axis,
Parallel side.
yeah. What is BA?
U.
U. Right. So BA is and what is DC?
U plus V.
This much. It's only right. Y U plus V.
Oh,
So
V. Sorry, sir.
yeah. Let's say that you have this coordinate, right? Let's say this is 1, 2, 4, right? So 5. So this is 5, right? From here to here, this is 5. So from here to here, this is B. From here to here, on the y-axis, these are the velocities. So these are U. So U plus and AD is how much? Yes. AD is how much?
T.
So this is RT. Now, you guys tell me that we want to prove B square minus U square equals to 2AS. Is that correct? This is what we want, right?
Yes, sir.
So in this equation, we have V, we have 2, we have A, and we have S. Now let us compare this with this equation. So we have S, we have U, we have V, we have T in that equation. Yes. We don't have T in this equation, right? Is that correct, guys?
Sorry, sir.
Yeah. So in this equation, let us compare. We have to reach here. We have to reach here, and in this formula, we have this B, we have Q, we have A, and we have S. But let us compare this with this. So in this formula, we have S, we have U, we have V, we have T. Do we have T in this equation?
No, sir.
So we have to get rid of this, right?
Yes, sir.
So how can we get rid of this T? We know that B or A is V minus Q by T. Right? We know that.
Yes,
So
sir.
we have to calculate T. This would be V minus Q by. Understood?
Yes, sir.
Let us replace the value of T from. So let me replace this and put the value of T from. So that would be S is half and U plus and T is B minus T. And this is B. So let us write this as B plus B. Right? 2 plus B I can write 2 plus 3 as 3 plus 2. Nothing changes. Right? Similarly, I can write U plus B equal to B plus B. But I cannot write 2 minus 3. This is not equal to 3 minus 2. Right? Only plus 1 is 3. Okay, so now you guys tell me that what is V plus U, V minus U? What is the identity? V plus U and V minus U. Yes, what is the identity V plus U and V minus U?
Sir, V square minus U square.
Square minus U square. And this is in the denominator of this both here. So this will become b square minus b square equals to 2. This is what we wanted. Any doubt?
No, sir.
Okay, so please help us out. So we wanted to prove the third equation, which is b square minus b square equals to 2. And if you have any doubt, if you guys have any doubt, please ask.
Finished, sir.
Finished, completed. Rishita, what about you?
No, sir. 1 second.
Okay.
Yes, I'm done now.
Yes, should I scroll down the screen?
Finished, sir.
Yes, sir. I'm done.
No, no. Okay, so yeah. Now the all parts are done. So let us know about more graph. Right. Please join now. Hello, Amna. Assalamu alaikum.
Walaikum Assalam, sir.
Was late, half an hour late.
Sorry, sir, I was fasting today.
Yeah. So I was also fasting. And okay, so you are in UAE, right?
Yeah, so actually 6:30
Ah,
is the Maghrib time.
oh, okay. Time is okay, understood. Yeah. So we only okay. So just take the screenshot. So one equation was left, right? One equation was left, which was the third equation, because we have proven the previous two equations. So one equation was left, so I just did that. You take the screenshot, and yeah, we use the same velocity time graph. So we use the velocity time graph, we defined the initial velocity and the final velocity, and then we just calculated the area of the graph, which would give the distance. So that is how we again solve this part. Please take this screenshot. Take it,
Yes, sir.
and this part also. Done.
Done, sir.
Okay, so the difference is only here. So t was not here in this equation, so we just removed t from the acceleration definition. So we removed t and then we got this was the only idea of this part. Now let us understand more graph part. So we understood the velocity time graph, right? In the velocity time graph, we understood that if we have so if we have we have t and velocity, right? So let's say that a particle starts from here, right? And let's say that a particle starts from here, okay? And yeah, so who has the greater initial velocity? So let's say this is A and let's say this is B, right? So you guys tell me that what is let me write this as, let's say this is A and this is B. So you guys tell me that A and initial velocity of A and initial velocity of B. So whose initial velocity is minimum? In this, by looking at this graph, what you can tell? Yeah. So any idea, guys? Whose initial velocity is minimum? So if I write the yes, yes,
No, sir.
Saki. No, no, I'm asking that whose initial velocity is A or B?
A.
A, right? It is starting from 0. So if I write the numbers, let's say this is 1, 2, 3, 4, 5, 6, right? So UA is 0 meter per second, right? This is in meter per second, and time is in second. And UB is how much? So this is UB is 3 meter per second. So we can say that UA is less than U, right? From the graph, we can identify that. And it has reached here. So B has reached here, and this A has reached here. Okay. So let's say that, and this is. So what can you say about final velocity of A and final velocity of B? Yeah, who has the highest final velocity?
Both of them are the same.
Yeah, so you see that this one is the highest velocity of A. So this is, let's say this is 3.5, and this is 6. So VA is lesser, 3.5 meter per second, and VB is 6 meter per second. So VB again is greater than, right? So from this graph, we can tell about this much. Is that correct? Yes. Is this understood, guys?
Little, sir.
Little. Okay, so okay, what we can do? Let us take one graph and then we will compare. So let me draw what is correct. Yeah, so let us take one graph at a time, and then if this is confusing, let us start with this one. So let's say this is time, right? And this is velocity. Okay, and let me give you some data. So let's say at this is t and this is, so at t equals to 0, b is 0. At t equals to 1, this is, let's say, 2. And at t equals to 2, this is 4. At t equals to 3, this is 6. And t equals to 4, this is 8. t equals to 5, this is 10. Okay, so these are the data there that are given. Now let us draw the graph. So let's say that this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5, this is 6, 7. And this is 2, this is 4, this is 6, this is 8, this is 10, and this is 2. So these are the data that are okay. And these are the coordinate points. This is x value, this is y value. So at 0, this is 0. So it is starting from what?
1 and 2.
It is starting from 0, 0, right?
Yeah.
So initial time is 0 and initial velocity is right. So it is starting from here. Now at time equals to 1 second, this is in second and this is in meter. So at time equals to 1 second, my speed has become 2 meters per second. So this is this point. And at time equals to 2 seconds, my speed is this. At time equals to 3, this is this one. And 8, this is this one. Right. Okay, so 4 is this one. And then this one, right? So these are the okay, this is the graph. Right. So this is the graph and this is the final velocity. So let's say this is 5 and this is 10. So how much is t is 5 seconds and how much is b?
10
10,
meter
right?
per second.
10 meter per second, second. So these are the information that we have. Okay, from velocity time graph. And we can also, from this graph, we can also calculate acceleration, right? So acceleration would be how much? This velocity minus this velocity by time, right? We can also calculate from this part also, slope of the graph. But let's let's calculate from this. This is 10 minus 0 by 5, which is 2 meter per second. So acceleration we can calculate, right? And what kind of, let's say that we calculate the acceleration from this point to this point. And so at this point, what is the acceleration? So this is this one and this one. Slope of the graph. At this point, this would be how much? 2 minus 0, 1 minus 0. So 2 meter per second. Similarly, at this point, this would be this one. So 2 meter per second again, 2 meter per second again, 2 meter per second again. So what kind of acceleration is this? Yes,
Uniform.
Uniform.
uniform acceleration. So you see that whenever we have this kind of graph, straight line, so we have uniform acceleration. Okay. So and then we want to calculate the distance. So to calculate the distance of this graph, what we will do? How did we calculate the distance? How did we calculate the distance, guys?
By acceleration.
Okay, so we just discussed the area of the graph. Whenever we have velocity time graph, whenever we have velocity time graph, so area under velocity time graph gives distance, right? And slope of the PT graph gives what? Slope of velocity time graph gives what? Yes. Slope of the velocity time graph gives what? Yes, guys. So we did this part just a moment. What is the slope of PT graph? Do you guys understand about the slope? Yes.
Yes, sir.
The slope of velocity time graph gives what?
Uniform acceleration.
Yeah, acceleration. Not a uniform, but acceleration. Yes, correct. So why are you not? Is that clear to you guys? These points are clear. Yes, are these points clear to you?
Yes, sir.
Amna and Akif, yeah. So again, we have to calculate the distance between 0 to 5 seconds. So how much distance is covered between 0 to 5? Right. So you guys calculate and tell. How much is the distance covered in the distance
Sir,
covered?
we can use area of triangle, right?
Yeah, absolutely correct. 0 to 5. Okay. So tell me, guys, what should be the distance? As Akif said, area of triangle. Let me name it as A. B. So how much would be area of triangle? A. Yes. How much is the area, guys? Yeah, who has got the answer? Akif, as you said, area of triangle ABC. So we know what is the area of triangle ABC. This is clearly a, yeah, this is clearly a right angle triangle.
25, sir.
25. So let us check that. 25. So this BC half base, let's say AC into B. So AC is how much? 5. BC is how much? 10. 25 meters. Absolutely correct. Yes, correct, Akil. So Rishita and Amna, did you get the same answer?
Yes, sir.
Okay, so if you have calculated this, then you guys tell me that how much is the distance covered So you guys tell me that how much is distance covered between 2 to 5 seconds and acceleration between 2 to 5. Calculate and tell. So from 2 to 5 seconds. What is the distance and what is the distance? So this we have done it already, but I'm repeating this. Yeah. Yeah. So did you guys get it? Yeah.
Doing, sir.
Yes. uh, 10 meter per second. 10 meter per second. We are calculating distance. 10 meters. Okay. So Akib and Rishita, what did you guys get?
I didn't got anything till now, sir.
Okay. And acceleration. What about acceleration now? Rishita, what did you get?
Sir, I didn't do it yet.
Okay, so now let me do this and you guys check whether it is correct. So we are calculating the distance covered from 2 to 5 seconds. So 2 second is this and 5 second is this. So area between 2 to 5 seconds. Right, area between what is the area between this. This is the what is the this shape? What is this shape?
Trapezium?
Trapezium. So we have to find the area of, let's say this is BC and let's say this is D. And so area of trapezium E, this would be equal to half sum of parallel sides and then height. So half sum of parallel sides are what? DE and BC. DE is how much? DE is how much?
Sorry, sir.
DE. DE or ED is how much?
2,
ED. ED.
4, 4, 4.
And plus what is BC?
10.
10,
10. 10. Right. BC is 10. And then height. Height is how much? This height. BC.
3,
3.
5 minus 2, which is this would be how much? Half and then 14 and then
21.
2, 3, 21 meter. Right. This would be the distance covered from the ground. And then acceleration would be how much? So acceleration would be v minus q by t2 minus t1. So this is v is how much? V is 10, u is 4 minus 5 minus. So this is 6 by 3 again. So which we already know because this is a uniform acceleration. So acceleration would be same. Is this clear to you guys? Any doubt from this velocity time graph? Yeah.
No, sir.
Okay. So please note it down and always keep in mind these 2 points. These 2 points are important. In velocity time graph, these 2 points are important. So note down this part and then we'll go ahead. So whenever you guys want me to scroll down the screen, you guys just
Finish, sir.
finish. So this part also finished.
Yes, sir.
Rishika and Amna, what about you guys?
Done, sir.
Yeah, so any doubt from this graph? Do you guys have any doubt?
No, sir.
Okay, so now let me read this part. Okay. So you guys saw this, right? And now let me draw one more graph. Now let us take one another. So, so the other graph is starting from, let's say, this is, now let me name this as A. Okay, so this was A. Now from graph B, and these are velocity. So these are velocity. So let's say that this is 4, 4, 4, 4. So this is this stuff. Okay, so this is This is B and this is understood. Is this clear to you guys?
Yes, sir.
So looking at this graph, this is what? So this is uniform acceleration, right? And this is what is the acceleration of this graph?
Uniform.
Acceleration is equal to slope, right? So you can see that in this graph, so velocity is changing or what? Velocity is changing.
No.
So if velocity is not changing, so acceleration would be off. Acceleration is change in velocity. If velocity is not changing, which means that acceleration is how much? Yes. So we know that acceleration would be slow, right? So for this case, let us find the slope from this point to this point. So slope would be how much? This would be 4 minus 4 and 5 minus 3. So 0 by 5. So 0. Acceleration is how much for this graph? Yes. Is that clear? This part we had already done this kind of these kind of situation we did earlier. So you guys have to revise. Okay. Firstly, I did all these. So who got disconnected? Okay. So we have done this part already, right? Different kinds of situation. So this was uniform velocity, acceleration was 0, and this was uniform acceleration, and this was non-uniform acceleration. So these kind of situation we have already, yeah. So is this clear to you, guys? Clear?
Yes, sir.
Is uniform. So this is uniform. This is acceleration equals to 0, which means uniform velocity. Clear? Now, if I draw and in this graph, if I ask you that who has the larger initial speed, A or B? Who has the bigger initial speed? Yes, Rishita, you tell me who has the larger initial speed, A or B?
Sir, B.
B, right? Because the B has the initial speed 4 meters per second and A has 0 meter per second, right? Now, let's say I draw a diagram like this. So let me draw a diagram like this one. So let's say this one. Okay. So let's say this is C. Now looking at C and A, right? Looking at C and A, who has greater initial velocity, UA or UC? Who has a greater initial velocity? Yeah. Or let me bring this diagram so that it is more clear. So let me draw the diagram like this. This is the diagram. So this is C. And Rishita, you tell me which has greater initial velocity, UA or UC? Which one has a greater initial velocity?
B, sir.
C, UA and between A and C. So UA is 0, UC is 8 meters per second. Right, so clearly UC is greater than UA. Clear? Is this clear to you? Clear to
Yes.
you guys? Now, if I ask you that who has the final velocity larger? So VC or VA? Final velocity, let's say this is at this point we are calculating. So let us skip that part. And so C and A. A is uniform acceleration. What is C? Is this a uniform acceleration?
No, sir.
It is not uniformly accelerated. How? Is it a straight line or a curve? Is this changing?
It is uniformly uniform acceleration.
Yeah. So A and C are uniform acceleration. Okay. B is acceleration equals to 0. So these are the information we know. Now, can you guys tell me that which has the greater acceleration, AC or AA? Right. Which has the greater acceleration? So acceleration is defined by what? In the graph, acceleration is defined by what? Yes, Akib, Rishita, and Amna. Acceleration is defined by what?
Slope.
Slope. Slope of the graph tells you that acceleration is how much. So in C and in A, which has the greater slope? So which has this length greater? This one or this one? Which one has the greater slope? A or C? Yeah. Which one has the greater slope? Can you guys tell? Yes. Can you guys tell me which one has a greater slope?
C.
C. Right? C has a greater slope. So Amna answer is C has greater slope. AC is greater than A. Rishita, what is your answer? And Akib, what is your answer? Quickly tell me guys. Which slope is bigger?
The AC.
AC slope is bigger. Okay, Akib, what about you? What about you? Yes, yes, Akib. What is your answer? Same. Yeah, Akib. Akib has. My voice is lagging. Okay. So Akib, don't. So let me talk about the. I guess you guys have forgotten what is slope. So let's say that. Yeah. So this is the angle theta. So let's say this is point. Let's say this is point X y2, y2, and this is point x1, y. So if I want to calculate the slope of this graph, so that is equivalent to tan theta. So slope is equal to tan theta, which is equal to, let's say, this is how much? Y2 minus y1, and this is x2 minus x. So slope is y2 minus y1, x2 minus x1. So this slope is given by this, and let's say that this angle represents the slope. Okay. So let's say that if I have this kind of right. So let's say this is theta 2. So which slope is bigger? This theta 2 or this theta? Which slope is bigger? Yes. Which slope is bigger? Theta 2 or theta 1? So I have this slope and then this slope. So which slope is bigger? Akib, Rishita and Amna. Which slope is bigger? Which angle is bigger? Theta 2, right? So this theta 2 angle is bigger, which means that this slope is bigger. So theta 2 is greater than theta, so which means that slope of theta 2 bigger than slope of theta. This is how we define. So in this case, this angle is right. This is angle. Let's say this is theta, and let's say this is some angle. Let's say this is some angle. So which angle is bigger, this theta or this theta? Which angle is bigger? Let me draw this angle here. So which angle, this angle or this angle? Which angle is bigger? Yes, Shita and Namna. Which angle is bigger?
Theta.
This theta angle is bigger, right? So which means that acceleration A would be greater than acceleration C. Understood? Or you can also calculate the slope from here. So you have this 5 second, you have this 0 second. So slope would be how much? From here, this is 10. So 10 minus this is 0 and divided by 5 minus 0. So this is 10 by 5, which is 2 meter per second square. And for the case of this guy, so this is 10 slope of C. This is 10 minus how much? 10 minus how much? From here to here, right? And from here to here. So 10 minus how much for C? 10 minus 8, right? 10 minus 8 and 5 minus 0. So this is 2 by 5, which is 0.4 meter per second square. So you guys can see that this acceleration is AC and this is AA. So we can tell that acceleration of A is bigger. Is that clear to you? Amna, Rishita and Akib, is this clear to you? So by looking at the slope, we can tell different kinds of things, right? So we can tell about the acceleration. Yes, Rishita and Amna, is this clear or I can explain it again? So is this clear?
Yes, sir.
Clear? Rishita, what
Yes.
about you?
Yes, sir.
Okay, so please note down this part. Please note down this graph, add this graph, and then write about these conditions. So please note down. And then we'll talk about, yeah, so quickly note it down, and then I will talk about the different kinds of stuff. Okay, so Akib has noted. Rishta and Amna noted.
Yes, sir.
Okay, so whenever the graph like this is given, so let's say you are given a velocity time graph, right? And they have, let's say, they have given this graph, and they have given, let's say, this graph. Okay, and this graph, so this is A, this is B, and let's say this graph, right? And let's say another graph, this one. So these are the graphs that you have. Okay, so let us forget about this for now. So this is what kind of acceleration? Yeah, this is what kind of acceleration?
Velocity time graph acceleration
Yeah, acceleration would be how much for this graph?
0.
Acceleration is 0. And which acceleration is bigger, A or B? Which acceleration is bigger? Yes. Whenever I ask you that which acceleration is bigger, you just think about the slope. So slope is angle. Which angle is bigger?
A.
A is bigger than this one. Yes. A is bigger than B.
No.
So
B is
yeah, so
that.
acceleration of B is greater than X. So this from graph we can tell about this. Is that clear to you guys?
Yes, sir.
Okay, so just remember these points, and I want you to. Okay, I will talk about that. So I will talk about that later, but let us talk about this relative velocity in one dimension. Okay, so relative velocity in one dimension. What is the relative velocity? So this comes due to the movement or simultaneous motion of two objects. So let's say that we are talking about two objects which are understood. So let's say that one case is that, let's say this is A and this is moving in this direction, and we have B which is moving in this direction. This has a velocity A and this has velocity B. Okay, is this clear? Yeah.
Yes, sir.
And the second case would be that, let's say this is BA and also this is understood. So
Yes, sir.
these are these two scenarios. And you see that we are only in one dimension. So A is moving in this way and B is not moving in this way. Right. So we are only in one dimension. Understood?
Yes, sir.
Okay, so for the case of relative motion, so let's say that two cars are moving in same direction, right? Or two trains are moving in the same direction. So if I talk about the relative velocity, then their velocity will seem to be increased or decreased. So when two when two trains are coming, right? Then when you observe those trains, so their velocity will appear to be increased or decreased. Yes.
Sorry, sir.
Let's say that two cars or two trains are coming in the same direction, right? So their velocity seem to be increased or decreased. This is what I'm asking. Or let's say that,
Decrease, sir.
yeah, let's say that one train is moving in this direction and another train is moving in the same direction. And then you saw it outside the window. So you will see the train velocity to be decreased or increased.
Decrease, sir.
Right. Whenever they are moving in the same direction, the velocity will appear to be decreased. And whenever they are coming in the same direction, their velocity will seem to be increased. So that is due to the relative velocity. Right. Relative velocity, what does it do? So the relative velocity is defined as let's say we are calculating the velocity of A with respect to B. So this is what? This is VA minus B. Okay. So let me write the vector form. So this is the velocity of A with respect to B. This is called the relative velocity. Okay. So when the two objects are, so there are two cases when two objects are moving in the opposite direction. Right. So I will only write the magnitude. So VA B would be VA plus B. Okay, I'm writing the magnitude. Right. And how can we understand this? So let's say that this is let's say VA, and let's say this is VB. Right. So how can I write VA in the vector form? VA vector would be how much? Yes, VA vector would be how much? Let's see that you guys remember vectors or not. So we are moving in this direction. Remember, this is what direction? So magnitude is given VA, and what is this direction? Yes, Akib, Rishita, Amna, what is this direction?
Positive.
What is so this is
I cap.
I cap. So this is VA I cap. And what is VB vector?
Minus I cap.
So minus VB I cap. Right. And if I calculate VAB, so this would be how much? This would be VAI minus of VB of minus I. So this would be how much? Minus minus I plus, so VAI plus VBI. So this would be how much? So VAB, this would be VA plus. This is what I have written. Whenever they are in the opposite direction, their velocity will add up. Is that clear? Yeah.
Yes, sir.
And whenever they are moving in the opposite or the same direction, when two objects are moving in same direction. So whenever they are moving in the same direction, so V would be VA minus V. Right, so you can understand this by this. So VAI and this is VBI. So VAB would be VAI minus of VBI, which is VA minus VBI. So magnitude is simply. Is this clear to you? Whenever they are in the opposite direction, so velocity add up. Whenever they are in the same direction, so velocity decrease. Understood?
Yes, sir.
Okay, so please note down this part and then we'll do question. And you guys, okay, so you guys will have a class assessment after this class. So that would be on relative velocity. And if you guys face any problem, so we will talk about the question in the next class. Please quickly note it down and then we'll do one problem. So when does this relative velocity arises? When does this relative velocity arises, guys? Yes. When does this relative velocity arises?
Don't know, sir.
Okay, the whole concept I did and then so this arises when two objects are moving, right? Up until now, we were studying one object which was moving. We were studying that one car is moving, one train is moving, and we were calculating all the physical quantities associated with that one. But in this case, in relative motion, two objects are moving simultaneously. So whenever you see two objects are moving, so only apply the relative velocity. Understood?
Yes, sir.
Yeah. So please quickly note it down and then we'll do one question.
Finished, sir.
Finished. Rishita and Amna, what about you guys? Finished?
Yes, sir.
Can you scroll down?
Yeah. So finish, Amna.
Yes.
Okay, so let us do this problem and you see that how this relative motion is. So two cars are moving or two cars
Sir,
are
can you scroll up 1 second?
okay. Do you have any doubt, Rishita?
No, sir. The second part. The second part.
The
Same
second
direction.
one. Yeah.
Yes, sir.
Okay, so two cars are started from A and B and move in the or move towards each other. Right, move towards each other with 40 kilometer per hour and let's say 60 kilometer per hour. Okay. And the distance between them, or let me write it this as okay, so after right 100 divided by okay, so let me write it as 20 and 30. 30 kilometer per hour, right? and the distance, not kilometer per hour, but meter per second. So 20 meter per second, 30 meter per second. The distance between A and B is, let's say, 100 meters, right? Find the time when the two cars meet. Okay. So, did you guys understand the problem? We have two cars, right? So, this is point A, and this is point A, right? So, this one. So, this is looking like a spaceship, but just assume this is a car, and they are moving towards each other. So, this is moving with 20 meter per second, and this is moving with 30 meter per second. And the distance between A and B is 100 meters, right? So now we have to find out that how much time it would take to these two cars to meet each other, right? This is 100 meters. So did you guys understand the problem? Yeah, understood the problem.
Yes, sir.
So these two cars are moving, right? So which speed we should take? Which velocity we should take? Yes. Which velocity? Whenever you see two things are moving right simultaneously, so we talk about which speed? Yes. Okay, it's already getting late, so let me do this problem for you, and then so they are moving in the opposite direction. Direction is opposite. So V of relative AB, this is 20 plus 30, which is 50 meter per second. So this is the velocity. And they have to meet at some point. So how much total distance is they have to cover? This distance is 100 meters. Okay. So time would be what? VAB divided, or distance divided by, which is 100 by 50, which is, so T is 2 seconds. Understood. So this D of A, distance covered by this A car would be 20 into 2, which is 40 meters, and distance covered by B car would be 30 into 2, which is 60 meters. So this will cover 20 meters, and this will cover 40 meters, and this will cover 60. Is that clear to you guys? Is this clear?
Yes, sir.
Okay, quickly note it down, and then please take the class assessment. So quickly note it down, and then log into your Learnivio account, and then take that class assessment. Whenever you guys have completed noting it down, tell. Done. And Rishita and Aki, what about you?
Yes, sir.
So are moving towards each other. Okay, so if this is completed, you guys log into your Learnivio account, and then open the class assessment section, and then just see the active test. So that would be on this relative velocity. please take that test, and whenever you have activated that test, tell. So whenever you guys find that test, tell me, and yeah.
Yes, sir. It has started.
Oh, you have started the test. Okay. Rishita and Amna, what about you guys?
Started, sir.
Yeah, Rishita, what about you?
I started, sir.
Okay, so I'm leaving, and whenever you guys complete that test, and please, so if you find any question which is difficult for you, tell me in the next class. I will discuss that question.
Okay, sir.
Okay, bye guys. Allah Hafiz. And you guys, please
Sure.